Okay, so those of you who are quarantined or absent or have been for the past several days, I'm sorry it's taken me a bit to get this video up, but we're going to go over how we calculate the protons, the neutrons, and the electrons of an atom. So a quick recap, an atom is any cluster of these three things: protons, neutrons, and electrons. And what we're doing in this exercise is keeping track of how many of each of these particles we're going to have. So long story short, we have this thing called the periodic table, and every box on the periodic table pertains to one chemical element. And each box is going to have four primary pieces of information. And so these pieces of information help you figure out what that atom looks like. So the first piece of information is the number at the top of the box. This is called the atomic number, and the atomic number is the number of protons in an atom. So remember that there's three things in an atom: protons, electrons, and neutrons. The protons have a positive charge. The electrons have a negative charge. In fact, electricity is just a bunch of free moving electrons. And then the neutrons, which has a poorly drawn zero in it, has a zero in it to mean that it's no charge. So it's neutral. It has neither a positive or a negative charge. So the way this works is that these guys, the protons and the neutrons, are in the center of the atom, which is called the nucleus. The electrons go around the nucleus. So if this is the nucleus right here that I'm hovering on right now, the electron is going to kind of orbit around the nucleus like that. And these are where the protons and the neutrons are. So the next step is every element is going to have a different quantity of protons, neutrons, and electrons. So this first number is the number of protons in each atom. So an oxygen atom, to be an oxygen atom, has to have 8 protons. If it had any other number than 8 protons, it would not be oxygen. It would be something else. This number is also called the atomic number. The next thing is anywhere between 1 and 3 letters in the box. These 3 letters are called the chemical symbol. Either 1 to 3 letters, that is. They are the chemical symbol. So instead of writing the entire name out for each element, we can just abbreviate it by calling it by its symbol. It's also very easy to write chemical formulas that way. For example, H2O is 2 hydrogens per 1 oxygen, which is water. So instead of writing hydrogen 2 oxygen, we are abbreviating it by writing H2O. The next obvious one is going to be the name. And then the final number, probably the most important number, or the most tricky at least, is called the mass number. Notice that every box is most likely going to have a decimal for a mass number. There are some exceptions, but the thing about the mass number is it is an average for all different varieties of oxygens. Some oxygens come with a mass of 16, some with come a mass of 17, some with come a mass of 15. So when you average them all out, you get about 15.999. No single atom has a decimal for a mass number. They all have a whole number. It's just when you put all the whole numbers together and you average them, you're going to get a decimal. So this is the average for all oxygens. What makes the mass number is the sum of the protons and the neutrons. The electrons do not account for any of the mass. So what I'm going to do right here is write P plus N. So the next step is that we are going to apply those 4 pieces of information in this chart down here. So I've posted a periodic table on Canvas, and you will use it to complete the chart. The first one is done for you. So if we look at the periodic table, which actually I need to get that out. So I'm going to go into here. Let's see what periodic table I got. There we go. We'll use this guy. This one's kind of highlighted, so bear with me. Here we have boron. Boron has a 5 up here, so that is the number of protons. So any atom to be boron will have 5 protons. The next thing about it is that it has an average mass of 10.81. So using this information, we're going to go back to our previous note, and we're going to fill it in. So boron's chemical symbol was a B. Its mass number in this case is 11. Remember, the average was 10.8, but because its mass number for this specific atom is 11, we have to work with this number. So to find the number of neutrons in an atom, which again are the neutral ones, you have to take the mass number and subtract the atomic number, which is the number of protons. So these two numbers are always going to be equal. You have to take 11 minus 5 protons to figure out how many neutrons are in your mass. 11 minus 5 will be 6. And then your electrons, for the sake of this activity, are going to equal the protons. The reason is that a proton is positively charged and an electron is negatively charged. So if you have equal number of positive and negative, you have no net charge on the atom, and that means that the atom will be stable. So for all working purposes, we're going to keep those numbers the same. So let's do sodium together. So I'm going to go back to my periodic table and find sodium. All we know about sodium is that its atomic number, which is again the number of protons, is going to be 11. That means that in its box, it should have 11 at the top. So we're going to go back and check out a periodic table and we find sodium. Sodium is in the third row, and because it's in the third row, its number is 11. So that means it's got 11 protons, which is why its atomic number is 11, and it has an average mass of 22.999. So again, that's the average. We're not actually going to use that for today. Its chemical symbol, however, is Na, so that's important. So we're going to go back and we access our note. We need to write the symbol. So sodium's symbol is Na. Its number of protons, again, was its atomic number, which is 11 protons. Electrons are going to be equal to protons, so we don't have a net charge of the atom. We have as much negativity as we do positivity, so this will be 11. The final thing is, how many neutrons do we have in the nucleus of the atom? So the next step is we take the mass number of the nucleus, which is 24. We subtract 11 protons from it, and we get a total of 13 neutrons. So that would be sodium. So we'll do one more, and then you can take it away from here. And if you have any questions, you can feel free to ask me. So in this case, we have yttrium, and I know that because I know the symbol. So basically, we have our clue that the chemical symbol is going to be a Y, and we have its mass number that is 89. We don't, however, have the atomic number or the protons available. So we're going to have to go back and check it out. You did, however, see the electrons. So for this activity, it would work to actually use the electrons to figure it out. But I want you to understand that the electrons don't have to equal the protons in all cases, so it's not necessarily a good habit to get into. We find yttrium based on its chemical symbol, which is Y, and its atomic number is, of course, 39. So because it's 39, that means it has 39 protons. Atomic number 39. 39 protons. For the purposes of this activity, the electrons equal the protons. The next step is we got to find the neutrons. If your mass for one yttrium atom is going to be 89, then you need to take 89, subtract 39 from it to get the number of neutrons. 89 minus 39 is 50. So that's all we're doing. So basically, at your leisure, we need to get this entire thing done. Now, it does get a little complicated because once we get past carbon right here, you don't have the number of neutrons or the mass number. So I actually have to give you some mass numbers so you can calculate the number of neutrons. So we're going to do, for this one, we're going to do 14. For calcium, we'll do 40. For barium, I think we're going to do 137. Whoops. Silicon will do a mass of 28. Argon will do 40. and magnesium will do a mass of 24. So based on these numbers, you'll be able to calculate the neutrons by finding the atomic number and subtracting it from that mass. Now what happens if you have the number of neutrons, for example, but you don't have a mass number? Let's do hydrogen. Hydrogen is the easiest element because it's the first one. So if we go to the periodic table, it's right here at the top left corner of the periodic table. It has one proton because its atomic number is 1. So we go back and we hit this document, and for hydrogen, we're going to write its name. And then we're going to write its total number of protons. So its atomic number is 1, its protons are 1. For electrons, it will be 1, but we have 0 neutrons here. So to find the mass, we need to add the protons plus the neutrons. So that would be 1 plus 0 equals 1. So oftentimes, hydrogen actually travels around without a neutron. It can have anywhere between 1 and 2 neutrons, but most of the time it doesn't have any. So anyway, that's how you would do it if you have the neutrons but not a mass. So go ahead, feel free to email me if you have any questions, and I hope that was helpful.